Hi, I'm Joan Carter. I'm the engineering faculty here at Inver Hills Community College. This is our engineering project workshop. Follow along as we see some of the students' engineering projects from this year.
All right, so this is a crystal radio, and what it's supposed to do is this antenna is supposed to be somewhere high up where it can have unobstructed access to AM radio waves. The device is only compatible with AM. And what happens then is it goes, like, there's actually no battery. So it's powered strictly by radio waves. So the radio waves go here, and this is the coil, and the coil resonates at specific frequencies. And these you see these wires that are kind of wrapped around the outside here? These are called turns. And the more turns you have, the more it's going to be able to resonate and the more you're going to be able to hear. And this is a tuning capacitor, so all you have to do is move this dial and it will focus in on specific frequencies or radio waves. Again, it's only compatible with AM, so especially these days it's kind of limited. But then it passes to the diode, which acts as a detector. It converts the current from alternating current to direct current, and it keeps the current flowing in one direction. So it goes 6 million ohms in this direction. And then you end up at the headphones, which once the audio electrical power is converted to sound power, you're going to be able to hear.
Okay, so this is a controller. It looks kind of weird, but it is the exact same thing as this. All of these buttons, these four right here, these are movement buttons. So this goes left, this is down, this is right, this is up. Same thing as the stick. These right here are the face buttons. So this would be A, B, X, Y. These right here, these are the exact same thing as these back buttons. So this would be this trigger, this would be this trigger, and these two would be the shoulder buttons. What this project in particular is to help with is mainly two things. One, carpal tunnel. When you're using a controller, it's a constant strain on your wrist to move the Joy-Con when you're playing these high-intensity fighting games. It can lead to carpal tunnel where pretty much your nerve gets pressed and leads to constant pain. This, your hand is always relaxed and it's just your fingers moving up and down. Huge. Can relieve so much stress and pain. The other thing is consistency. In a fighting game, you often have to make inputs, like moving the stick from the down position to the forward position, or from the back position to the forward position. If you mess it up, the move that you're trying to do in the game might not come out. On this, if you want to do a quarter circle, you just quickly press the two buttons. So you just slide your finger across, that's a quarter circle input. That's the exact same thing as doing this. Consistency and health were the main prospects of this. This project cost me like $80. Buying one of these, closer to $200, $300. Really, all I did was take an Xbox, take all the internals out, drill holes in the top, attach my buttons, attach a circuit board to the bottom of it, plug the buttons into the circuit board, do very minor programming, get something to extrude the connector from the motherboard out, and that's it. Very simple, quite effective. Went perfectly as I wanted it. In the future, I would have probably used something other than the 360 case because it's a little lightweight and fragile, so I'm worried about it breaking. But other than that, I'm really happy with this project.
So we are the Inver Hills Rocketry Club, a part of the engineering club. This year, we've got a rocket that will be going about 3,700 feet up on one flight and about 2,300 feet up on another flight. It's a canvas phenolic tubing, so it's an epoxy, high temperature epoxy with a canvas lining, so it's pretty strong. The competition this year is to reduce spin of the rocket as much as we can through non-mechanical means, so no moving parts. We're taking a few angles to try and ensure that there is as little spinning as possible. It's probably going to be impossible to totally remove spinning. We're pretty hopeful of that. Albert's been doing the coding for that to kind of not only run the camera, but also all the sensors that will give us our information. We've flown a couple rockets in the past. One best built rocket as voted on by all of the other teams. And yeah, it's a pretty fun time.
Okay. So I'm in charge of the electronics. If you want to show the electronic bay, This is the electronics bay for an older rocket. Pops out. It's nothing in this one, but the one that's going in our main team build rocket is going to have a mini computer that controls things like a camera, barometer, senses barometric pressure, accelerometer, and a GPS. And a few years ago, we won 3rd place at the NASA Midwestern Regionals. That's about it.
So my name is Kelly Balin. I'm the lead structural mechanical engineer for the IMPRESS and EXACT satellites, which are basically mirrors of each other right here. I'm also the chief engineer for our new satellite that was just NASA approved, and that's called the Despina. That is a 6U satellite versus what is called the 3U satellite. I have also designed and been a part of 2 other instruments. One is called Alexis, otherwise known as Advanced, and I clearly misspelled that there, Advanced Lagrange X-ray Spectrometer. And the other one is IMPRESS 2. So it's kind of a derivative of the main satellite. This piece of instrumentation has already been approved, and this will go up on the GRIPS 2 NASA Balloon Telescope in the Antarctic this year. This one has not yet been approved, but hopefully will be soon. And it's a piece of instrumentation that will go on the European Space Agency's Vigil mission, and that will do space science from Lagrange 5, hundreds and hundreds of thousands of miles from Earth. Despina, this is a brand new mission that is a full satellite in its own rights, and that one's just been approved by NASA. We're starting to gear up on that. As far as the other missions go, EXACT and IMPRESS are basically twins of each other. IMPRESS is for NASA and EXACT is for the Air Force. IMPRESS will be basically spending most of its time staring at the sun, and it's just gonna be sitting there doing a lot of space science, having to do with M-class solar flares. But EXACT will actually be doing a completely different mission with the same sort of instrumentation. That's going to be pointing at the Crab Nebula, and it's specifically going to be looking at a pulsar, and that pulsar gives off a very specific radio frequency as it spins. And what it can do is it can figure out if it's moving away or moving towards that as it rotates around the Earth, and it can use that to geoposition itself with a ground satellite. So the ground satellite station paired up with that helps us to create 2 different situations. One is a hardening, meaning it's no longer able to be spoofed because it's not on the Deep Space Network. So it's very useful for the Air Force for that reason. But the other reason that is much more to heart for me is the fact that it takes these off the Deep Space Network, freeing up some of the bandwidth for more science to be done in Mars, past Neptune, Voyager 1, Voyager 2, stuff like that. The way it does that is currently when a satellite is rotating around Earth, it knows it's in a particular orbit, but it doesn't know where in that orbit it is. So it uses a ground station and it uses the Deep Space Network, which is a series of satellites that are positioned from here all the way out to the outer planets. And it pings those. And it gets a response time back that's consistent with a particular position that it's at. And then it looks at that ground station and it can triangulate. So we're taking it off of that Deep Space Network. We're letting it read that pulsar radio frequency, and that's how it's going to be able to find its location. So all of these different missions are really, a lot of it is about the science that's behind it to allow us further access to space. Being able to know where you're at in space, being able to know what sort of space weather is going to happen, solar flares, etc., plasma bursts, things like that. So I don't do the physics side of it, I do the mechanical engineering side of it, but both sides need to exist together in order to come up with a coherent mission for this sort of thing. If you don't have the science, there's no reason to have the mechanical. And if you don't have the mechanical, then you're not going to get any science. So that's where I am. I'm at the intersection of the 2 right now.